Hi folks, Dr. Tom McNamara back again for our course in college algebra. Doing something a little different with this video. I wanted to make sure we all understood kind of the mechanics of answering questions about quadratic functions here in my math lab. So I've got an example question pulled up for us right here, and it says we're going to use the graph to find the following, and it gives us the graph. So all we have to go on is this picture. No formula for the function, nothing like that. The good news is all we need is the formula. If you look back to our previous video, how we would draw the graph of a quadratic function, we looked at a couple different cases. We looked at the vertex form and we looked at general form. And in both of those cases, if the lead coefficient was positive, the graph would open up. We can see in this picture the graph opens down. So the lead coefficient is negative. We would select that as our answer, and then we click check. Okay, we got it. Great. And there's a bunch of other questions it asks us. The vertex of a quadratic function, which is a critical piece of information to know, well, that's where the graph turns round. Okay, so we can see it's right there. We do have to be kind of careful because it is going to ask us to do both the x-coordinate and the y-coordinate. Okay, so the coordinates of the vertex are -2, 0. As we can see, this graph has been moved 2 units to the left and has not been moved vertically at all. Check answer. Great, we got that one too. The axis of symmetry. Now, you'll remember I actually made quite a bit of use of the axis of symmetry when I was plotting these graphs by hand. And the axis of symmetry is a vertical line going through the vertex of your quadratic function. So in this case, x equals -2. That's the axis of symmetry. All right, so moral of the story, if you know the vertex, then you automatically know the axis of symmetry. And since it's a vertical line, the equation will always be x equals. If I put in a equation that said y equals a constant, that would be a horizontal line. X equals a constant is vertical. F of x is increasing. Okay, well, it's asking us for the answer in interval notation. We can see the graph is sloping up here until we get to x equals -2. So -infinity, I'll select that down here, comma, -2, parenthesis, and decreasing for -2, comma, I select the infinity down there, parenthesis, check my answer, got it, wonderful, we're doing great here. The domain is -infinity to infinity. Okay, for any quadratic function, that will be the domain. You can use any x value that you want in your quadratic function. So the domain is all real numbers, -infinity to infinity every time, if you're dealing with a quadratic function. Now here they're asking me about the range. Okay, and I notice on my graph, there is a maximum y value. The graph opens down, so the vertex is the highest point on my graph. So I can get anything up to 0. So -infinity, comma, 0. Okay, I want you to notice a very tiny difference between the answer I just put in and the answers that I put in previously. Notice I have a hard bracket there, a square bracket, rather than a parenthesis. If we look back to the video that we did on interval notation, we'll see that the square bracket indicates that value is included in the set, and we can see we can get an output value of 0. You put -2 into the function, you get 0 out. That's what it means for -2, 0 to be on the graph. I don't even know the function's formula, but I know if I did have that formula and I put -2 in, I better get 0 out, because -2, 0 is on the graph, meaning I can get 0 as an output. 0 is part of the range. Okay, so that should be a hard bracket. All right, great. So the quick overview of how to answer a question like this on My Math Lab, and realize that is extremely closely related to what we've been talking about in class, okay, and what we will talk about for the rest of this course. If you have the functions graph, you have tons of information. You can answer tons of questions about the function's behavior from the graph. You don't really need the functions formula if you have an accurate graph.